Picture this: a nation with the fourth largest railway network on the planet, carrying 8 million passengers daily, suddenly finds itself unable to move forward. Trains are built, stations are ready, but there's one critical problem: no wheels to put them on. This isn't fiction. This is India's railway reality in 2024. In May 2022, something unusual happened. The Indian Ministry of Railways quietly signed a procurement agreement with Taiwan Heavy Industry Corporation, a Chinese state-owned manufacturer. The purchase? 39,000 railway wheels. The price tag? Approximately 21 million US dollars, or 1.7 billion Indian rupees. But here's what raised eyebrows. India agreed to pay nearly 2% more per wheel than previous market rates, and they insisted on doing business with China, despite years of geopolitical tensions between the two Asian giants. This raises a fascinating question that goes beyond simple economics. Why would a nation with aspirations of becoming a global manufacturing powerhouse pay premium prices to import something as fundamental as train wheels from its regional rival? The answer reveals a complex web of broken promises, international conflicts, manufacturing limitations, and the harsh realities of global supply chains. If you're interested in understanding how global economics and geopolitics intersect in unexpected ways, make sure to subscribe and hit the notification bell. Today, we're diving deep into a story that exposes the hidden vulnerabilities of one of the world's fastest-growing economies. To understand why this wheel shortage became a crisis, we need to first grasp the sheer scale of India's railway infrastructure. The Indian Railways network stretches across more than 67,000 kilometers of track, connecting nearly 8,000 stations across the subcontinent. Every single day, over 13,000 trains crisscross the nation, forming the circulatory system of the world's most populous country. But here's the problem. This massive network is aging rapidly, and it's showing dangerous signs of strain. Most of India's railway infrastructure was built decades ago, during the colonial era or shortly after independence. Many trains operate far beyond their intended capacity, with passengers crammed into overcrowded compartments, sometimes even riding on rooftops or hanging from doors. The combination of outdated equipment, insufficient maintenance, and overwhelming demand has created a perfect storm for disaster. The statistics are sobering. In 2021 alone, India recorded nearly 18,000 railway-related accidents. These incidents claimed the lives of more than 16,000 people, with an additional 1,800 suffering injuries. To put this in perspective, that's roughly 44 people dying every single day in railway accidents across India. But the crisis goes even deeper. Between 2017 and 2021, approximately 100,000 people lost their lives in incidents related to Indian railways. That's equivalent to the population of a mid-sized city simply disappearing over 5 years. These aren't just numbers. They represent families torn apart, communities devastated, and a transportation system failing its most basic obligation, keeping people safe. Recognizing this crisis, the Indian government launched an ambitious modernization program. The centerpiece of this effort was the development of the Vande Bharat Express, a semi-high-speed train that would showcase India's manufacturing capabilities to the world. The name itself, which translates to "Salute to India," was chosen to evoke national pride and self-reliance. After 18 months of development, India unveiled its new train, capable of reaching speeds of 160 kilometers per hour. Government officials proudly labeled it "Made in India," presenting it as evidence of the nation's growing technological prowess. Media events were held. Politicians gave speeches. The train was positioned as a symbol of India's arrival on the global stage of advanced rail transportation. But beneath the patriotic rhetoric lay a more complicated truth. While the train carriages were indeed assembled on Indian soil, they were built under licensing agreements with Germany's Linke Hofmann Busch Company, commonly known as LHB. More significantly, between 70 and 80% of the critical components, including the braking systems, electrical equipment, and crucially, the wheels, had to be imported from foreign suppliers. The Made in India label, while technically accurate for the assembly process, masked the reality of India's dependence on international supply chains for essential technology. This dependence became particularly problematic when it came to wheels. Train wheels, especially those designed for higher-speed rail, aren't simple metal discs. They're precision-engineered components that require advanced metallurgy, sophisticated manufacturing processes, and rigorous quality control. And India, despite its size and industrial ambitions, lacked the capability to produce them domestically at the required scale and quality. Facing this manufacturing gap, India needed to find a reliable international supplier. Here's where geopolitics entered the picture. At the recommendation of the United States and other Western allies, who were keen to support Ukraine's economy and reduce India's reliance on Russian or Chinese suppliers, India decided to place its trust in Ukrainian manufacturers. In August 2021, the Indian Ministry of Railways signed a contract worth $18 million with Ukrainian industrial companies to supply 30,000 train wheels specifically designed for LHB carriages. The deal seemed perfect. Ukraine had Soviet-era heavy industry expertise, competitive pricing, and strong backing from Western nations. According to the agreement, the entire order was scheduled for completion and delivery by the end of 2022. Everyone involved was optimistic. India would get the wheels it desperately needed. Ukraine would secure valuable hard currency for its struggling economy. Western allies would strengthen strategic partnerships in the region. It appeared to be a win-win situation. Then February 24, 2022 arrived. When Russian forces crossed into Ukrainian territory, they didn't just trigger a military conflict, they shattered global supply chains that countless nations had come to depend on. Within weeks, Ukrainian factories that had been humming with production ground to a halt. Workers abandoned assembly lines to join territorial defense forces or flee to safety. Supply chains collapsed. Transportation networks were destroyed. Industrial facilities became military targets. The contract with India, like thousands of other international agreements, became collateral damage in a conflict that would reshape European security and global commerce for years to come. India's dilemma: trains without wheels. For India, the timing couldn't have been worse. The government had already invested heavily in building new Vande Bharat Express train sets. The carriages were manufactured, the interiors fitted, and the electrical systems installed. These modern trains sat in railway yards across the country, gleaming symbols of progress that couldn't move an inch. They were, quite literally, trains without wheels. Initially, Indian officials believed the conflict would be brief, a matter of weeks, perhaps months at most. They decided to use this temporary disruption as an opportunity to accelerate domestic manufacturing capabilities. If India could figure out how to produce high-speed rail wheels domestically, it would never again find itself at the mercy of international suppliers or geopolitical disruptions. Government ministers announced initiatives. Funding was allocated. Research institutions were tasked with solving the technical challenges. But as engineers and metallurgists began working on the problem, they quickly discovered that manufacturing high-quality train wheels is exponentially more complex than political leaders had imagined. The science of wheel manufacturing, why it's so difficult. So, to understand why India struggled with this seemingly simple component, we need to understand what actually goes into making a train wheel suitable for high-speed rail. The process begins with a single piece of steel billet, a solid block of specially formulated metal that will eventually become a wheel. This isn't ordinary steel. It's a highly specialized alloy with extremely precise chemical composition. The raw material must first be heated to over 1200 degrees Celsius, hot enough that it glows white and becomes malleable. Once heated, the steel billet is placed into a massive hydraulic forge, machines that can exert thousands of tons of pressure, and shaped into the basic wheel form. But forging is just the beginning. The wheel then undergoes a carefully controlled heat treatment process called quenching and tempering, where it's rapidly cooled and then reheated to specific temperatures. This process determines the wheel's internal crystal structure, which directly affects its strength, durability, and resistance to cracking under stress. After heat treatment comes precision machining. The wheel must be cut and shaped to tolerances measured in fractions of a millimeter. Any deviation can cause vibrations at high speeds, accelerated wear, or even catastrophic failure. Finally, each wheel undergoes rigorous non-destructive testing, ultrasonic examination, magnetic particle inspection, and stress analysis to ensure there are no internal flaws that could lead to failure during operation. But perhaps the most challenging aspect is the steel itself. The material specifications for high-speed rail wheels are extraordinarily demanding. Consider just one requirement. Oxygen content must not exceed 0.0002%. That's 2 parts per million. Achieving such purity requires advanced steelmaking technology and meticulous process control. Similarly, non-metallic inclusions, microscopic impurities in the metal, must be kept to an absolute minimum and distributed uniformly throughout the material. Why such stringent standards? Because a single wheel failure at high speed can derail an entire train, potentially killing hundreds of people. The wheels must withstand enormous forces. Each wheel on a high-speed train can experience loads exceeding 20 tons while simultaneously enduring extreme thermal stress from braking. They need to last for hundreds of thousands of kilometers without developing cracks or excessive wear. Currently, only 5 countries possess the complete industrial ecosystem needed to manufacture wheels meeting these specifications at commercial scale: China, Japan, Germany, France, and Italy. Each of these nations invested decades building the knowledge base, developing the specialized equipment, and establishing the quality control systems necessary for this level of precision manufacturing. India, despite having a substantial steel industry and engineering expertise in many areas, simply didn't have this specific capability. Building it from scratch would require years of investment, technology development, and operational experience. And India didn't have years. It needed wheels immediately. The conflict drags on. India runs out of options. As 2022 turned into 2023, and 2023 stretched into 2024, the situation in Ukraine showed no signs of resolution. The conflict that many Western analysts had predicted would last weeks had become a grinding war of attrition. For India, each passing month meant more idle trains, greater strain on its existing railway network, and mounting political pressure. India's operational railway system was already running near maximum capacity before the modernization program began. Now, with new trains built but unable to enter service, the burden on older equipment grew even heavier. Delays increased. Overcrowding worsened. The risk of accidents climbed higher. Transportation analysts warned that if the situation wasn't resolved within the next year or two, India's railway network could face systematic breakdown, a scenario that would paralyze commerce and daily life for millions of people. Faced with this impending crisis, India had to make a pragmatic decision that would override political considerations and nationalist sentiment. The government quietly initiated a new emergency procurement process, this time looking eastward to the one country that could deliver what India needed when it needed it. That country was China. Turning to China, a partnership born of necessity. In a move that honestly surprised many international observers, India approached Chinese manufacturers about supplying the critical wheels. And, in an interesting twist, even before formal bidding processes concluded, Indian officials had basically announced their intention to partner with Chinese companies. Now, why the apparent urgency? Why bypass the usual diplomatic posturing? The answer is simple. China is the only country in the world with both the manufacturing capacity and the production flexibility to fulfill such a large order in a compressed time frame. Chinese factories can retool quickly, scale production rapidly, and meet international quality standards, all while offering competitive pricing. By late 2023, India finalized a contract with Taiyuan Heavy Industry Corporation for 39,000 wheels, 9,000 more than the original Ukrainian order. The total value reached 1.7 billion rupees, which is approximately 21 million US dollars. Notably, the price per wheel was 1.68% higher than what India had agreed to pay Ukraine. But, given the rupee's volatility and the urgency of the situation, Indian negotiators considered this acceptable. According to the terms of the agreement, Taiyuan Heavy Industry would complete production by October 2024, with full delivery expected by year's end. For India, this timeline offered hope that the Vande Bharat trains could finally enter service and begin relieving pressure on the overburdened railway system. Indian industry experts acknowledged the reality openly. One specialist admitted publicly that domestic manufacturing capacity simply couldn't meet the demand for wheels, axles, and other critical components, which is precisely why the Ministry of Railways had no choice but to look abroad. However, this cooperation came with an unusual condition that reveals another layer to the India-China relationship. China explicitly required that India pay at least 60% of the total contract value up front before any wheels were manufactured or shipped. This demand raised eyebrows in international trade circles. Typically, large contracts between nations involve relatively modest advance payments, often just 10 to 15%. With the balance paid upon delivery or in stages as work progresses. This arrangement protects both parties. Buyers don't pay for goods they haven't received, and sellers have guarantees that customers won't walk away after work begins. So why did China insist on such a substantial prepayment from India? The answer lies in previous business dealings between Chinese companies and Indian government entities. Dealings that had left Chinese executives wary of India's payment reliability. Consider the case of BYD, the Chinese electric vehicle manufacturer. A few years ago, BYD secured a contract to supply 300 electric buses to India. After signing the agreement, India paid only 50% as an initial advance. The contract stipulated that remaining payments would be made in 2 subsequent installments. However, Indian officials then requested to consolidate these payments into a single final payment, a change that BYD, hoping to maintain good relations, agreed to accommodate. But when the final payment deadline arrived, the Indian government delayed. Days turned into weeks, weeks into months. The payment was ultimately delayed by 3 full months. BYD executives reached out repeatedly. Chinese government officials raised concerns through diplomatic channels. Indian counterparts offered various explanations and assurances. Eventually, under mounting pressure and after considerable diplomatic maneuvering, India made the payment. This incident, while ultimately resolved, left Chinese businesses deeply cautious about India's creditworthiness and payment discipline. In subsequent negotiations, Chinese companies adopted a more protective stance, insisting on larger advance payments to minimize their financial exposure. The wheel contract fell under this shadow. Chinese negotiators made it clear, 60% up front or no deal. India, desperate for the components and lacking better alternatives, agreed to the terms. When news of the Chinese deal became public in India, the reaction was far from the celebration one might expect for a major infrastructure contract. Instead of praising the government for finding a solution to the wheel shortage, many Indians expressed frustration, disappointment, and even anger. To understand this response, we need to consider the information environment in India regarding China. For years, certain media outlets and political commentators have portrayed China in predominantly negative terms. Stories emphasize border disputes, economic competition, and alleged security threats. This steady drumbeat of anti-China messaging has shaped public perception significantly. A substantial portion of the Indian population has come to view Chinese products as inferior. cheap knockoffs or low-quality goods that can't compete with Western or Japanese alternatives. Many Indians genuinely believe that made in China is synonymous with poor craftsmanship, despite the fact that many of the world's most sophisticated electronics, from smartphones to computers, are manufactured in China to exacting specifications. When Indians learned that their government had chosen China to supply wheels for the prestigious Vande Bharat Express, many felt betrayed. Social media erupted with criticism. Questions flooded newspaper comment sections. Why not Japan? Why not Germany? Why are we helping China's economy when they're our rival? The sentiment was particularly strong regarding Japan. India's partnership with Japan on the Mumbai-Ahmedabad high-speed rail project has been heavily promoted in Indian media, often highlighting Japan's legendary Shinkansen bullet train system as the gold standard of rail technology. Many Indians assumed that if Japan could build an entire high-speed rail system for India, surely they could supply something as simple as wheels. This public reaction reveals a disconnect between perception and reality, a gap between how citizens imagine global manufacturing works and how it actually functions. India's faith in Japanese manufacturing excellence wasn't entirely unfounded. Japan's Shinkansen system has operated since 1964 with an extraordinary safety record, carrying billions of passengers without a single fatal accident caused by derailment or collision. Japanese engineering precision is world-renowned, and the technology transfer partnership seemed like a natural fit for India's ambitions. However, the relationship between Japanese promises and Indian results has been more complicated than the optimistic press releases suggested. In fact, Japan's own railway industry had recently been rocked by a significant scandal that undermined confidence in its quality control processes. Investigations revealed that certain Japanese manufacturers had been falsifying inspection data for railway wheels, manipulating test results to make substandard products appear to meet specifications. The scandal exposed systematic quality control failures at companies that had built their reputations on reliability and precision. For India, this revelation was troubling. If Japanese companies couldn't be trusted to honestly report their own test results, how could India be confident in the quality of components they might supply? Moreover, the flagship Mumbai-Ahmedabad high-speed rail project, the showcase collaboration between India and Japan, had become a cautionary tale in infrastructure development. Announced in 2017 with great fanfare, the project was supposed to demonstrate that India could leapfrog directly to world-class high-speed rail, bypassing intermediate development stages. The original budget was estimated at $12.8 billion, with completion targeted for 2024. Japanese officials promoted the project as a demonstration of their technological leadership and commitment to India's development. But as construction progressed, or rather failed to progress, problems multiplied. Land acquisition proved far more difficult and time-consuming than anticipated. Environmental clearances faced legal challenges. Coordination between state and federal authorities created bureaucratic bottlenecks, and costs spiraled dramatically upward. The current estimated price tag has reached $30 billion, more than double the original projection, while construction completion stands at less than 50%. Most significantly for India's immediate needs, the completion date has been pushed back to 2028 at the earliest, with many experts predicting even further delays. The project that was supposed to showcase Indo-Japanese cooperation had instead become an example of unfulfilled promises and mounting frustrations. Against this backdrop, China's track record looked considerably more appealing. While China might not have Japan's historical prestige in railway technology, it had something arguably more valuable: a proven ability to deliver large infrastructure projects on time and within reasonable budget parameters. China's dominance in manufacturing infrastructure components isn't accidental. It's the result of decades of strategic investment, industrial policy, and accumulated expertise. The country has built not just factories, but complete industrial ecosystems, networks of suppliers, logistics systems, quality control infrastructure, and skilled workers that can respond to demand with remarkable speed. Consider the numbers. China produces more steel than the rest of the world combined. It manufactures a significant portion of global railway equipment. Its factories have supplied components for high-speed rail systems in countries across Asia, Europe, and Africa. This isn't about cheap labor anymore. It's about industrial capacity at a scale that no other nation can match. When India needed 39,000 precision-engineered wheels delivered within a year, only China's industrial base could credibly promise to meet that deadline. German manufacturers would need to navigate complex EU regulations and potentially multi-year production queues. Japanese companies were tied up with their own domestic needs and international commitments. Italian and French manufacturers, while capable, work at smaller scales and longer timelines. China's Taiyuan Heavy Industry Corporation, by contrast, could retool existing production lines, source materials from domestic suppliers, and leverage established quality control systems to fulfill India's order without disrupting other commitments. This flexibility, born of massive scale, gave China a unique competitive advantage.